Hey guys, welcome back. We're talking about the four parts of a vector today, which is much like the four coordinates of a point. Now, I'm not going to waste your time or insult your intelligence about point C, the rectangular coordinates, but let's look at its polar coordinates. If we were to take a circle, give me a second. If we were to take a circle and overlay the center to the origin, the distance C is from the origin is one polar coordinate, and the other polar coordinate would be that direction, which is positive, or that direction, which is negative. Keep in mind that this right here, this radius, is also the hypotenuse of some right triangle. Wow, that's fantastic. All right, number two, keep in mind it's Socrative. If I'm talking about number 1, number 2, or number 10, or whatever, I'm talking about that number. And we're talking about the polar coordinates here, and that would be point H. Keep in mind, point H has two rectangular coordinates. Let's do another one for whatever reason. Number 3. Negative 330. Remember, negative is clockwise. That doesn't sound right, but it is. G has two rectangular coordinates. They're contained in that triangle, X and Y. All right. The four parts of a vector are much like the four coordinates of a point. Two of them are rectangular, also called component form. I will use both of those. Be on the lookout. All right, and then the other parts are polar. There is a magnitude, wow, a magnitude, and a direction. We just looked at that. Vectors are very, very useful. They can help us model the flight of this airplane, hope it lands safely, and the flight of this rocket. It can model how Steve is pulling on Dooley to make sure that Steve doesn't hurt Dooley. We would report him. The flight of the baseball can be modeled by vectors or help to be modeled by vectors. Steve pushing on this trash can and the force of friction resisting him are vectors. We'll deal with all of that later. Let's keep it simple today. Let's quickly review some simple trigonometry. You should really be looking at that and thinking, I can solve for X and I can solve for Y very, very easily. I have faith in you. All right, use cosine 26 equals X over 200. The old adjacent over hypotenuse thing, and then it would solve out like that. If you have any problem with that, you're going to have to contact me. And then sine would be done the same way. Well, what if this triangle modeled the flight of this airplane going 200 miles per hour in that direction? Let's overlay that to an XY coordinate plane. Then the polar vector of this plane is 200 miles per hour. It's velocity or speed in the direction of 154 degrees. Now, we work pretty hard on that. You should recognize that the direction is from there. All right, that rectangular form or components are 179.76 right here and 87.67 there. Now, you are going to have to recognize that this thing is going left and up, and we know that left to be negative. All right, I like that. We just wrote a vector in polar and rectangular forms. Now, you might be thinking like the thinker here, man, why would we even want to interpret this thing in component form or rectangularly when polar makes way more sense? Well, if old man wind is blowing across the plane or in helping it or hurting it in any way, and we had to add the vectors, then those vectors are going to have to be added in rectangular form. Now, we're not doing that today, but we will do that today. We're keeping it simple. All right, there is a vector. I want you to write it in both polar and component forms. I am going to go walk my dog because he's been bothering me and I got to go walk him. I'll be back. I'm back. That's a polar vector, so by all means, we should be able to write it in polar form that the speed or the hypotenuse or the magnitude is 40, and it's in the direction of 195 degrees. The components are found with cosine and sine. Now, I do want to point this out, that one side of your triangle needs to be the x-axis. You do not want it to be on the y-axis. You may think about putting it on the y-axis, but don't do it. If you do that, it'll disassociate cosine with x and sine with the component y. We don't want to disassociate that. All right, so let's write the component form that this piece right here is 38.64, and the y component is 10.35. And then we've got to understand that it's going left and down. Now, if you don't understand where that 15-degree angle came from, you need to contact me because we worked on that. All right, number 5. again, pause the video, see if you can come up with the polar and component rectangular forms or component form. All right, it is a polar vector, so the magnitude is the hypotenuse, which is 512, and the direction is 320. We get that 40-degree angle right here by subtracting from 320 from 360, and we get an x component of 392.21 and a y component of 329.11. And then we need to see that this thing's going right. So the x component is positive and down, the y component is negative. Now I may ask that at Socrative. If I say number 5 at Socrative, what's the component form or rectangular form? Then type exactly that. No spaces, please. All right, so essentially what we just did is convert a polar form to rectangular or components, and then we want to do that the other way around. Okay, so there's a rectangular vector. The vector can be anywhere. This is true, that we can move it anywhere we want. And if we kind of thought about or moved the beginning to the origin, then the end point of the vector would be the coordinates of the vector, left 4 down 2, C. Now, we really don't want to do that. We kind of just want to leave the vector where it is and start at the beginning and go to the end. Beginning to end, what a concept. And so the beginning is here. We go left 4 and we go up 2. Left 4 up 2 is B. All right. Number 8, start at the beginning, go to the end. Right 2, down 4, F. That simple. Now, we'll do a lot of this. Be prepared. Beginning, right 4, down 2. All right, so enough of that. Now, what I want to do to finish up here is take that vector and write it in both rectangular form and polar form. Keep in mind, rectangular is called component form. All right, and so rectangular would be -3, -2, and we would write it with those symbols, darn it, -3, -2, and that's component form. And then let's look at the next slide for polar. All right, let's look at what we have here. Keep in mind, the hypotenuse is the magnitude. Everybody should be able to do the Pythagorean theorem to find that to be root 13, and the magnitude is root 13. At Socrative, you can either, I'll give you the option to type root 13 or you can make it a decimal. And then if we were to find theta right here, now theta is not the direction, alpha is the direction, but theta is found this way, and then we'd have to add 180 to it to get 213.69. Almost done. All right. Moving on. I think this is the last problem. Again, let's write that in both rectangular or component form and in polar form. That's left 5. That's up 2. So component form is left 5, up 2. Simple. Let's look at the next slide for polar. We're going to use the Pythagorean theorem to find the magnitude. So for the polar form, it is root 29. Again, at Socrative, you can type root 29 or 5.39. Don't do both. All right, and the direction would be that. That's going to keep us on this interval 0 to 360 where it's positive. I mean, yeah, you could do that, but we're not really going to do that too much for now. All right, and so we would say, let's tangent theta equals 2 over 5. Well, it's always going to be the y component over the x component. That's another reason why we want a side of the triangle on the x-axis. Anyway, and so we would do 180 minus theta this time to get 158.20, 158.20. All right, hey, I feel good. We're done. I do have a cameo shout out today. I want to shout out to all the brave men that serve our great country in Pearl Harbor, Hawaii on the USS Illinois. That's very personal to me. Thank you, men. And I want to say to them, fair winds and following seas. All right, guys, I had fun. I hope you did too.